Welcome to the soldering video for your series versus parallel board from eLearnTronics. What we're going to do today is go through the soldering. You have a bag of parts. You've got the kit, and I'm going to walk you through how to turn that kit into this finished board. There's a separate video that explains what this board is all about, what it demonstrates, the series versus parallel nature of resistors and capacitors. Today we're going to go through how to solder it, how to get all of these little globs of solder on here. This is not a soldering tutorial though. If you have never soldered anything before, then I suggest that you check out Dave Jones from the EEV blog. I could put together a soldering tutorial, but he's already done it and he's so much better than I am. So just listen to him. Go over there, it's on YouTube, check it out, give him a like, give him a subscribe if this is something you're interested in, and then come watch this video and put together your board so that you can learn a little bit more about electronics. We have our electronics learning board here. This is the series versus parallel line. We're going to take our components out of the bag now. The first thing that we have is our actual PCB circuit board. It's in white with black writing on front and back. So we'll set that aside. We have our 9-volt to barrel jet connector. We'll set that aside. You won't need that until the entire board is constructed. And I'm just going to dump out all of these components so that we have them on our workspace. There's not too many to deal with. You can put the bag aside for later. The first thing you're going to notice are these 4 big honking 1000 microfarad capacitors with a purple case. The barrel jack connector, you should have 1 of those. The LEDs, you should have 4 of them. They may not be green, these are green, but you should have 4 of them. They'll look the same, they may just be a different color. Next, we're going to grab our 4 hex standoffs, as well as the 4 screws that we'll use to attach them to the board. That's really going to be the last thing we're going to use, so you can really set those aside. Then we have my 2 favorite components in all of electronics, DP-DT switches. And then we have 8 different resistors. Now the values are determined by the bands here, and we'll go over in just a bit how to figure that out. But right now the important part is that you have 8 of them. Now let's start thinking about tools. You're going to need your circuit board, of course, some solder. It doesn't have to be in a fancy holder like this. You'll need a soldering iron. Again, it doesn't have to be fancy. It can just be a cheapo one. It just needs to melt the solder. Now when we decide how we're going to attack this, we want the components that sit the most flush on the board. That's usually going to be the resistors, unless you have like surface mount components. But you can just kind of work through all of the components and just see how high do they sit off of the board. You want the stuff that sits the flattest first, and then the stuff that really sticks off the board to be last. So in this case, again, in almost every case, it's going to be the resistors. So we'll start with those. Okay, so now that we know that we're starting with the resistors, how do we know which value we have? There's charts available all over the internet. You can also get printouts to keep in your toolbox, but we're going to look at the bands on the resistor body itself. There should be 3 to 5 colored bands on there, and that'll help us determine the values. Now going from left to right, and this doesn't really show up on camera, but I can tell you it's brown, black, orange, and gold. Brown corresponds to 1, black means 0, orange is our multiplier, and that's 1,000 times. So 1 0, that's 10, times 1,000 gives us 10,000. Our second resistor, it has yellow, purple, brown, and gold. Yellow is a 4, purple is a 7, and brown is a 10x multiplier, so that gives us 47 times 10, 470. So that's how you determine the values. Okay, so we need to pull off the paper packaging. You're just going to hold the 4 resistors in one hand and just pull off the paper packaging in the other. It's very simple. And there you have 4 resistors that have been liberated. Now we're starting with our 10Ks, and there's 4 spots that those are going to go. They're all marked with the word 10K. They're all going to be over on the resistor side, and it's going to be in these 4 spots. The way that we place a resistor is we're just going to bend the leads. You can do this by hand, or you can get tools. Unless you're placing a lot of resistors, you really don't need the tool. You're just going to slide them in to each side, following the silk screen, and then push it down, and it should be sitting flush against the board, and you'll have the leads sticking out the back. You can set down the board in between and just bend the leads, or you can bend all the leads at once. And what we're doing right now is actually a term called PCB stuffing. We have the printed circuit board, and now we're just stuffing all of the components into it. So there's 3 of the resistors. The 4th one tried to get away from me there. We'll bend the leads. And go ahead and slide it into its last spot. Alright, so now we have our 4 resistors there for the 10Ks. Now we can move over to the 470 ohm resistors. We're going to have essentially 1 in each section. So we'll have 1 in each of our resistor sections. So we have this one here, and then this one here. Again, they're marked 470. And then the over in the capacitor section, we're actually using those to make sure that we resist or reduce the current rather going into our LEDs. So just some lead bending time. Again, it's not tough. You can get a tool if you want, but you know, it's part of the fun to really get your hands into your electronics and work with them. And there we go. We have our circuit board ready to solder. Got all 8 resistors in there, and we're just going to flip it over onto the table. Do it quickly, otherwise they'll fall out. Now, this is not a soldering tutorial, like I said. If you want a good tutorial, go check out Dave Jones. But I can tell you, one of the things we're going to do here is only solder 1 point on each resistor. And tin my tip here, and I'll show you why we're only doing 1 point in a little bit, but you don't want to lock it in by doing both leads of the resistors. I'm going to move my solder over here. Alright, and we're just going to get to it. Now if you don't want to go watch the whole tutorial real quick, you're going to touch the tip of your soldering iron to the board and to the lead, but not to the solder itself. You want to heat up the board and the lead, and then you're going to touch the solder to that meeting point and let the board and the lead actually melt the solder. You don't want to touch the solder directly to the tip of the soldering iron. So there's going to be 8 points on this initial pass, and you'll see why we're doing that in just a second. It's less important with the resistors. It gets more important as we move along. Now we'll flip our board over and oh, I missed one. Get the last point. Alright, now we'll flip our board over, and we're going to notice, well, we want to, alright, these are all pretty flush. Sometimes you'll have a component lift off the board a little bit and it's not completely flush. And just to demonstrate that, I'm going to melt one of these leads and purposefully do a poor job. Okay, so we have a resistor that it's not flush with the board. So the way we're going to fix that is by actually re-melting or reflowing that solder with our soldering iron and pushing down that component. You must be careful when you do this. These are intensely high temperatures. You will burn your skin immediately if you touch the soldering iron or the lead itself. So I cannot overemphasize that you should be very careful. If you don't want to do this, you can actually use your work surface itself to push on the component. That's another benefit of working from the most flush to the least flush. And it can take a few tries. You can also wear some heat-proof gloves if you want to be really safe. Here, I'll actually show you. I'll use the board. All right, and now we have all of our resistors are completely flush. Doesn't that look pretty? Now that we're happy with our first leads, we're going to go through, clean it up, and do all of our additional leads. So it's going to be 8 more soldering points. You get a lot of practice putting this board together. It's one of the things I love about it. Almost there. You know, take your time. Again, be careful. Remember, it's better to take your time and not burn yourself than to rush and get a horrible disfiguring scar. Doing this safely, you'll be okay. This is a safe hobby as long as you are following safe procedures. So there we have it. We've got all of our resistors nicely soldered, and I'm going to come through and just do a spot check. Now you may notice there's some brown residue around these soldering joints. That is the rosin, or basically the thing that helps the solder to flow. That is actually in the middle of that solder wire. If you don't like it, you can get some rubbing alcohol and go to town and clean it up. I personally don't mind it, but it does show up a bit more on the white boards. So I've got one joint that wasn't quite what I wanted. And now we're going to clip the leads. We don't want these big things of wire sticking out, so use some flush cutters. If you don't have these, pick them up. They're like $7. If you don't want to, you can use a lot of pliers have little wire cutters that'll get the job done, but these are like the most helpful things ever. They'll cut through just about anything. So I highly suggest that you go and pick up a pair. These are from Hako or Hako. I'm not sure how they pronounce it, but there are dozens of different brands out there. You can get them on Amazon. You can get them at hardware stores. Home Depot has them. Harbor Freight has them. They're available just about anywhere. You should absolutely get a pair. I save the leads because they're very helpful for prototyping. But you don't have to. You can recycle them or throw them away. All right, so we have our resistors down. Next, we need to figure out what our next component is going to be. So we're just going to hold the components on the board. Well, that switch looks pretty good. Let's see. I know it's not going to be the capacitors. It might be the LED. Let's hold them next to each other just to see. Nope, it looks like the switch is a little bit flatter than the LED. So that's where we're going to go next. So we've got our 2 switches. These are non-polar, just like the resistors, so it doesn't matter which direction we put them in. There's 6 holes and 6 leads. They can be a little tough to match up, but once they get in there, you should be good. We'll turn it over, and once again, we're going to solder 1 lead on each component. This is pretty much consistent for everything that you solder. Take a look here. They look pretty good. That one's not quite what I'd like, so I'm just gonna again put my finger on the one side. Just tap it with the soldering iron. Sorry, this isn't quite on camera. Just tap it with the soldering iron, and then that'll loosen it up. We can reset it where we want it. And this other one doesn't look all that great either, so I think I'm gonna go ahead and touch both of them up. Reflow the solder, align it like you like it. Now, if you're not OCD and you don't want these, you don't care if they're not perfectly straight or perfectly level, you don't have to do this. But if you want a nice looking circuit board, you can have this out and display it. And we're just going to hit the other 5 leads on each switch. Now while I'm doing this, I should mention I am using a fume extractor here, and I highly recommend that you do the same. These are potentially dangerous fumes. If you don't have a fume extractor, I would recommend getting a fan nearby, or worst case scenario, be by a window, or at the very least make sure you are in a very well ventilated area. But these fumes can be dangerous, particularly if you're using leaded solder. Alrighty, and there we have our 2 switches. I'm just going to check my handiwork, make sure that they look okay, make sure I don't have any bad solder joints. And yeah, they look good, and yep, they're switching. I love these switches so much. They're just, the click that they give is so satisfying. Next up, most flush piece for our board is going to be our LED. Now this is a polar component. That means that it matters which way we put it in the board. You'll notice that the 2 leads are different lengths. One is the anode and one is the cathode. The longer pin is the anode, which connects to the positive side of our power source, and the shorter end is the cathode. Now if someone's trimmed the leads or you forget which is which, there's a flat side on the LED, and that corresponds to our silk screen. So you can see here, there's a flat side on the silk screen, and you're not going to be able to see it on camera, but the flat side on the LED should match up with that. Now it can be tricky to spot the flat side on the LED, but you'll definitely be able to feel it. So we're just going to place our 4 LEDs on our board, making sure to drop one for good measure. And there we go, all 4. Now with LEDs, this is really when we want to just do the 1 lead at a time, because these things almost never stay flush. So we'll go ahead and hit all 4 initial leads. Make sure that your soldering tip is clean. So you'll see I'm not the greatest soldering master in the world, but it gets the job done. You really don't have to be an expert to put together these boards. All right, ready? Ooh, that is ugly. So you can see these are almost never flush on the board when you solder. So we'll put 1 finger on the back side of the LED. Try to get a good demo here. Just barely reflow it. We don't want to overheat it. Just enough that we can push it through. There we go. Now LEDs will become very flush on the board, but it does take a little bit of work. That one actually looks okay. Off to number 3. I will say it's very satisfying to fix LEDs in particular, because they go from just being ugly to just these perfect little domes of light right there on the circuit board. So we'll get LED number 4. And what's good is, once they're in there and the solder has cooled and solidified, they're not going to move. They're basically tacked on there. And then we can go in and hit the other leads. So check it, make sure that it's good. You can still do this if you've already soldered both leads, but it is much more difficult because you have to get both through holes melted simultaneously. And you can move the soldering iron back and forth, and it is doable, but it's so much easier to do it this way. Okay, so we've almost got all of our LEDs soldered on there. And again, just like in everything, we want to make sure that our soldering iron is clean. See the fume extractor. Sometimes I'll hold the tip right there and just let it kind of suck off those fumes after I've tinned the tip. And check our joints and we'll remove the leads. Again, I save them, you don't have to. There we go. This is really starting to look like something now. All right, another easy one. Capacitors or barrel jack connector. Obviously it's the barrel jack connector. This thing will only go in one direction. It uses these big giant holes, but you'll notice the connector doesn't have giant leads. It's basically flat. This requires a lot of solder to get it right. Like a lot of solder. And because we're using so much solder, this is going to get very, very hot. You want to be careful not to actually start to melt the barrel jack connector. I have done that several times. You're putting a lot of heat into this to add so much solder. We're still just going to do 1 point. It's hard to see on camera, but that was a lot of solder that I just put in there. Now we're going to let it cool off because, again, we added a lot of heat and there's a lot of mass to hold that heat right there, and it is rip-roaring hot. So I'm going to reflow it a little bit and get it flush. Again, being careful. I cannot overemphasize. There's a lot of heat getting stored in there. You can burn yourself. I have burned myself. So be careful. So we're going to hit the other 2 joints with our gobs and gobs of solder. All right. Now let's check the joints. They look okay. If you want to, you can trim the barrel jack connector. It does sit a little bit up off the board, but we're going to use the standoffs, so it's going to be raised up off the surface anyway. Yeah, it's still pretty hot. So, I mean, you kind of can, but you know what, just leave it. It's a nice rounded edge anyway. Yeah, I mean, the leads are all kind of pointy. That's why we have the standoffs, because these can scratch up table surfaces. And the standoffs help with that. Okay, now the moment we've been waiting for, the big capacitors. These are 1,000 microfarad. Capacitors are also polar components, meaning it matters which direction you put them in the board. The shorter lead is going to correspond to the negative side. On the board, the black silk screen is where you want the negative side pointing. So you can base this on the lead lengths, but really the important part is just that negative stripe, that white stripe with the negative sign, is on the darker side, or really pointed towards the bottom of the board. So we're just going to stuff all 4 of these in there. And you want to double check that they're in there correctly. If you solder these in incorrectly, you can unsolder or desolder and remove them and then resolder them, but it's a pain that you really don't want to go through. All right, so now that we're ready on these, we're going to flip them over. I like to kind of hold them with one hand and flip them with the other. This is not going to sit super flush. But again, we're just going to hit 1 lead per component, and then we'll help them get flush. Now, if you wanted to, you could prop something up underneath the other side of the board. That might help, but I mean, we're going to get this flush no matter what. It's probably going to be a little off no matter what. So just dive in. I find that it's better to dive in. So 1 lead per component, per capacitor. And yep, so I mean, I could have just used this little guy, actually, my little lead collector, but whatever. This is real world example, and what a surprise, it's ugly. So you should be familiar with this process now. Reflow, push the component down flush. We don't want to drive too much heat into these capacitors. You can actually overheat them. It's unlikely, but don't just sit there with the soldering iron right on the lead. You can damage them. I never have, but something to be aware of. And number 4. This is really starting to look like something special now, isn't it? So we've got our 4 capacitors on there. We're just going to double check that the negative stripes are all pointed in the same direction. And that's towards the bottom of the board, towards the switches. Again, we can fix this. We don't want to have to. So we'll go in and just hit our final 4 leads. And we are just about there. Solder, solder, solder. Hopefully by the end of this project, you're a little bit better at your soldering than you were before. So we want to check our solder joints, make sure there's no cold solder joints or, anything with too much solder, not enough solder. Now's the time to do it. When the leads are still there, it's easier to fix these problems. Once you've clipped the leads, you can fix it, but it's a little trickier. Well, I'm satisfied, so I'm going to clip these leads. If you're not, go back and fix your solder joints. Clippy, clippy, clippy. The flush cutters, I think, are probably my favorite tool in all of electronics. And just life in general. I use them constantly everywhere. All right, that is it for the soldering. So I'm going to retin my soldering iron. And I'm going to flip it off because no sense wasting that electricity. Put away my solder. Just as a reminder, you should probably wash your hands after handling solder, especially if it's leaded. You don't want to touch that solder and then put your hands in your mouth. Final step. We're just going to put on our hex standoffs. There's 4 spots, the 4 remaining holes in the board. You're going to slide in the screw from the top, and then with your other hand, just screw on the standoff. You don't need a hex wrench or anything. These don't have to be super, super tight. These aren't really supporting anything. We're just using them to keep them off of the table so that we don't scratch it up. Because these leads, like I said before, they are kind of scratchy. Now, I really love these standoffs. I think they give the boards just a great design aesthetic. They just look so much more professional with the standoffs there. And you're going to save your table surfaces at the same time. Got number 4 in there, and there you have it, the completed circuit board. Now we can plug in our 9-volt battery, put it into our 9-volt to barrel jack connector, and then plug that into the onboard connector and start flipping switches. Now I'm not going to explain right now what's going on. There is a separate video that explains what's going on that makes these LEDs behave differently. But there you have it, guys. You have a fully completed circuit board. So watch the other video to see what's going on, to learn a little bit about series versus parallel. And with that, thank you for soldering with me today. I hope you enjoyed it, and I hope you continue your electronics journey.